Bismillahirrahmanirrahim. Assalamu alaikum, dear students. We are now starting the first lecture for week number 10 for our course of communication systems. In this week's discussion, we will be talking about some fundamental concepts related to digital communications. As I have previously mentioned as well, that we will be taking another course which is related to digital communication in next semester. So the details of many topics will be discussed in the next course, that is the course of digital communication and information theory. However, there are few basic concepts that you need to know at this stage. So we will try to summarize those concepts related to digital communication in this week number 10's discussion. So we know that the digital methods of communication, they are slowly replacing the analog communication systems. There are number of reasons uh, uh, because of this transition, because of which we are facing this transition. First is the digital processing has become more cost effective and practical as compared to analog communications. Secondly, the advent of computer systems, they have given rise to have ways for direct transmission of digital data, because the digital data generally comes out of computers directly. In addition to this digital data, of course, one of the major major use in communication systems is the voice communication, which is inherently analog in nature. However, there are certain ways that we can transform this analog signal into digital form. So if we can easily transform digital analog signals to the digital form, eventually we can transmit it through our digital systems, utilizing the advantages that we gain from the digital systems. So these are the few important aspects that we observe, which lead to the tremendous growth in digital communication systems. First of all, the computer systems, they have their use have been increased for over the years. So eventually we need to have ways to transmit data from computer systems as well. Moreover, if we compare the analog transmission methods with digital transmission methods, we would see that there are number of advantages that we can get from the digital transmissions. So because of those advantages, people are converging their attention towards digital communication, and that's why we see the transition from analog systems to digital systems. And most importantly, the voice communication, which is the primary use in communication systems, it is being converted to analog to digital communications over years. So modern voice communication systems are based on digital methods. So we see that the digital communications is gaining rapid attention from all over the world. So as I mentioned, there are certain advantages that we observe in digital communications when we compare it to the analog systems. So let me quickly summarize those advantages that we generally observe in digital systems. Firstly, because in digital signals we usually work on binary communication. So binary signals, they are more immune to noise and interference as compared to the analog signals. So although noise can cause errors in digital systems as well, but the amount of error that is generally observed in digital systems is way smaller than what we generally observe in analog communication systems. So that's why because of this immunity to noise, we generally prefer digital systems when we have choice over analog systems. There are specific signal processing and coding schemes that are applicable or can be easily incorporated in digital systems. For example, we can use a specific type of code in order to provide error detection and error correction capability in the data that is being transmitted from the digital systems. We know that the noise may cause errors, but for digital systems, we can introduce the capability of detecting those errors or even correcting those errors. So that is a good advantage in digital systems. Digital systems, they are more compatible to time division multiplexing, which is actually easier to implement than the frequency division multiplexing, which is commonly used in analog systems. So the multiplexing that we incorporate in digital system is easier as compared to the analog systems. Digital ICs, they are very small and easier to make. They have very short production cycle. So eventually those ICs, they enable us to have digital systems developed very fast and very efficiently. And moreover, these digital ICs, they provide great processing capability for digital systems. There are a number of digital signal processing algorithms which are available for digital systems, which can provide different functionalities to digital communication. For example, encryption algorithms, we can simply incorporate an encryption algorithm to establish a secure digital communications, which is rather harder to achieve in analog systems. There are certain advantages with digital system, but there are some disadvantages as well if we compare it with analog communication systems. So first of all, the most considerable thing regarding digital systems is the bandwidth. The bandwidth requirement for digital transmission is significantly larger as compared to the analog systems. Let me give you a quick example. For analog voice communication system, we typically need a bandwidth up to maybe 4 kilohertz. But for the same transmission in digital system, depending on the digital scheme implemented, you require maybe up to 8 times higher bandwidth, say for example 32 kilohertz. So although depending on digital requirement, this bandwidth may go higher. So the bandwidth requirement is for digital systems is significantly larger as compared to the analog systems. Secondly, the digital circuits, they are generally more complex than analog circuits. So what is the difference between digital and analog systems? So if you try to compare those systems, so we will see that for digital signals, the waveform, it comes from a finite set of waveform shapes. Whatever signal you are incorporating, it comes from a finite possibilities of waveforms. Say for example, if you are working on a binary communication systems, in that case you will be dealing with only two possible waveforms. One waveform that will be used to represent binary 0 and another waveform that will be used to represent binary 1. So we would be working on a finite set of waveforms. If we compare this thing with the analog, in that case theoretically there are infinite number of possibilities of waveform in case of analog communication, because there is no definite shape, and theoretically we need to have an infinite resolution of those waveforms. This difference that we work on a finite number of waveform shapes causes significant change in the perspective from the receiver point of view, because at the receiver side we want to exactly reproduce whatever signal was transmitted in the from the transmission side in case of analog signal. So in analog signal we want to exactly reproduce the signal. However, for digital we do not want to reproduce the signal, rather we want to decide or determine which of the waveforms was transmitted. So at the digital receiver we need to make a decision that if we transmitted a binary 0 or a binary 1. So even if there is a shape change in the waveforms, we still are able to make the decisions or correct decisions at the receiver side. So that is a big advantage from perspective of digital communication, that by making a correct decision even with the contamination of noise and interference, we can establish a secure and reliable communication in the digital systems. So this is an illustration of a basic block diagram of digital communication system. So at first sight, you would be needing an information source. Of course, information source is something which generates some information for the digital systems. Typically, the information source is analog in nature in most of the communication systems. Say, for example, if we are using a voice communication system, so the voice signal which is generated from any human source is basically analog in nature. So we need to use an input transducer in order to transform that analog voice signal into a digital form. Sometimes we have other forms of data, so we have to transform that data into digital form so that it can be transmitted over the digital system. So the first point or first function which a digital signal has to go through is the conversion from an original form of data to the digital system. Secondly, we use a source encoder. What is a source encoder? Source encoder is actually encode your information in binary digits or bits. So it generates bits corresponding to the to represent your information. Actually, the source encoder tries to generate bits in such a way that the number of bits which are used to represent the information, they are minimized. So it tries to generate minimum number of bits that can be used to transmit the complete information. Without any loss of information, we try to transmit it tries to generate some bits. So basically it tries to reduce any redundancy if there is possible of reduction of any redundancy. So it searches for those redundancies and remove those redundancies so that we can transmit the data with minimum possible number of bits. The next block is the channel encoder. The channel encoder is actually a block which generates some error detection or error correction capability in the digital communication. So basically what it does, it takes the information which is coming from the source encoder and it adds some non-information bits which are commonly named as parity bits. So it adds some non-information bits. So those additional bits, they do not contain any information, but they are added with a certain rule or in a specific fashion, so that if any error appears during transmission, it can be detected at the receiver side. So this channel encoder generates the error detection capability, and in specific cases it may be able to generate the error correction capability. So it may be possible to make a code word in such a way that if the error occurs during transmission, so that error can be automatically corrected from the can be automatically corrected at the receiver side without any retransmission. So next block is the digital modulation. So we have previously discussed the modulation aspect in digital systems as well. We know that there are two types of modulation cases. If we are working on the baseband signal transmission, in that case we try to represent the digital information in form of pulses. So those pulses, they are also a form of modulation, because we use a specific waveform pulses to represent the digital information. So this type of modulation is sometimes called the baseband digital modulation, or sometimes we name it as pulse modulation. Alternatively, in some cases, we need to have the sinusoidal carrier incorporated in the systems. So in that case, we transmit the signal over a relatively higher frequencies. So that becomes a band pass signal. So that type of modulation scheme is generally named as digital band pass modulation, where you use sinusoidal carrier to represent the digital information. After modulation, the digital data is transmitted from the channel, and of course the channel carries the analog waveform, which can be in form of pulses for baseband transmission, or in form of the sinusoidal functions in form of in case of the band pass modulation. So channel, generally there are some unwanted effects which are generally attributed to the channel. For example, the addition of noise and interference, they are commonly attributed to the channel. If we look at the receiver side, in digital receiver, the first stage is the digital modulation, or the detection method, which I previously mentioned that in digital modulation, digital demodulation, the demodulator actually tries to identify which of the waveforms were transmitted from the transmitter side, because whatever you receive, that will be contaminated by noise, or maybe in some cases in interference and distortion. So that distorted version of the original information is received at the receiver side. So the receiver tries to compare that received signal with the original waveforms, and make a decision that what waveform was transmitted from the transmitter sides. So once the information is demodulated, the whatever demodulated information is recovered, that is sent to the channel decoder. The channel decoder actually compares the received binary data with the original rule that we used to incorporate in the channel encoder side. So on the basis of the rules that we set at the encoder side, the channel decoder makes a decision whether there is an error during transmission or not. If there is an error detected, so if the decoder is capable of correcting that error, it actually corrects that error. But if the decoder is not able to correct that error, it will request the transmitter to resend the signal, so that the transmission is successfully achieved. So sometimes the decoder has to request for the retransmission, or sometimes it may be able to correct the errors which occur during transmissions. After making the corrections or retransmission, the channel decoder removes the non-information bits or parity bits that were added by the channel encoder, and after removal of those non-information bits, the whatever bit stream is received, it is sent back to the source decoder. And source decoder actually reverses the process what the source encoder incorporated, because it actually tried to reduce the redundancies in the information. So source decoder will reinsert those redundancies and recover the original information which was transmitted from the transmitter side. And of course we need to use an output transducer in order to convert the received signal into the original form. Say for example, if the original signal was in the voice form, So output transducer will take that information coming out of the receiver and will convert it into the voice form, so that the signal can be delivered to whatever destination it is intended for. So this is a basic block diagram of a digital communication system. A basic system is represented like this. I tried to briefly explain the function of different blocks that we generally incorporate in our digital communication systems. In the subsequent slides, I have actually uh, uh, provided a summary of the discussion that I just did for different blocks of the digital communication system. So the source output, that can be a digital or analog, but we need to use uh, a transducer to convert the information into digital form. In case of analog signal, of course, we need to converted it into digital form using an analog to digital conversion by the process of sampling and quantization, and then the source coder removes any redundancies in the signal to generate a bit stream at the output. The channel encoder actually takes k information bits and add some n minus k non-information bits to generate a code length of n. These non-information bits, they are used to exercise control over errors for the detection or correction of errors. So there are two parameters which are commonly used for the channel encoder. The ratio n by k is generally named as redundancy, or sometimes we use another ratio which is k by n, which is sometimes called code rate. The modulator actually takes those binary sequences and makes the waveforms suitable for transmission over the channel. And of course, channel actually carries that information, and the receiver collects that information and tries to reverse all the processes that were incorporated at the transmitter side, so that the original information is received at the receiver. So this is also the basic description of an analog communication system. So if we try to illustrate a baseband system in simple sense, so what we observe, there are number of functions that need to be incorporated in the digital form. So first thing, what functions are needed depends on the original form of information. If your information is in the digital form already, for example, the information which is coming out of the computers directly, so in that case, the digital information can be directly transmitted from the digital systems. So that digital information is directly sent to the pulse modulator, so that the pulse modulator generates the pulses corresponding to that digital information that can be transmitted over the channel at this side. However, in some cases we have textual information. Textual information is commonly used for many communications. For example, the email, the information that we input in the email is actually in form of text. So we write some text consisting of the English characters. Say for example, we have like number of characters, 26 English characters plus some alphanumeric characters, including the numbers from 0 to 9, plus some symbols like plus, minus, and punctuation marks, comma, full stop. So all those characters, they actually form the textual information. In order to represent that textual information, we need to use some type of encoding scheme. So there are number of encoding schemes that are incorporated in such scenarios. So there are standard encoding scheme. For example, ASCII codes ASCII codes are standard codes which actually generates the binary information corresponding to the text which is input to the signal. So it is one type of the code which we commonly use. If the information is in analog form, that need to be digitized, and that digital information is digitized by using an analog to digital converter, which actually performs number of functions. The first step in that analog to digital conversion is sampling. So the analog information which is input to the system is sampled, and then this information is quantized to convert those samples into a finite number of symbols. So those samples are converted to into a finite number of symbols, and then we use an encoder, which is sometimes called pulse code modulation as well. So that encoder is actually generates the binary information corresponding to the number of quantized level that has been established in the quantization process. So that those bits which are generated from the encoder, they are then sent to the pulse modulator, which generates pulses, and then it is transmitted from the channel. Similarly, if we look at the receiver side, the first step at the receiver is actually demodulation or detection. In the process of demodulation and detection, we try to make a decision that what information or what waveform was transmitted from the transmitted side, because the waveform that we receive at the receiver side is actually not in the original shape because of the addition of noise, information, and the distortion. So even with those perturbations which we observe in the waveform, we are able to make decisions, and after that decision we recover the original bit stream which was transmitted from the transmitter side. If the original information was originally in digital form and we need the information in the digital form at the output, so whatever we detect that will be directly sent to the receiver because the information which is received is in the digital form. However, for cases where we do not need the information in digital form at the information sink, we need to transform that information into original format. So in that case, if we have textual information at the receiver side, we need to use a decoder to regain that textual information. So decoder takes that binary information, and based on the standard code like ASCII code which was used to transform the textual information into binary sequences, so it will recover the original textual information by converting the binary digits to the text, and then the textual information is provided to the sink in form of text. If we need to have an analog information, if we transmitted an analog information from the transmitter side, of course we would be needing the analog information at the receiver side, say for example the voice signal. In that case we need to incorporate a digital to analog converter in the analog systems. So that digital to analog converter is basically implemented by using a low pass filter. So practically a low pass filter can perform the function of the digital to analog conversion, provided we have appropriately adjusted the frequency of the low pass filter or bandwidth of that low pass filter. So from that low pass filtering process, actually the digital information is converted back to the analog information, which is then delivered to the information sink. So you can see that in this way we generally achieve the digital transmission for the baseband systems. And similarly, if we need to incorporate a band pass system, in that case we need to have another block where we incorporate the sinusoidal carrier, and then that sinusoidal carrier generates that baseband band pass signals so that it can be transmitted from the channel. So for today's lecture, we have taken some fundamental discussion related to the uh, digital systems and how the information flows through digital system, highlighting some of the basic blocks that we generally incorporate in the transmission of digital systems. In our subsequent lectures, we will be briefly discussing these blocks. I will try to explain the function of each block in some detail. Of course, I will be avoiding some mathematical description in those details, because the mathematical description you will be taking up in your next course of digital communication. So I will leave that mathematical forms to the next semester's course. But for the time being, we will be having some theoretical discussions related to these blocks, and how the different blocks they perform and they interconnect with each other in order to establish this entire digital communication system. So for this lecture, I will stop the discussion here. Inshallah, we will be continuing the discussion in our next lecture as well. Thank you all.